In this lesson, we will discuss about extreme value problems. In this section, we will be dealing with word problems that, when translated into mathematical expressions, requires the determination of the maximum or the minimum value of a certain function. Okay, let's start with this first problem. Problem 6.1. Two positive numbers have sum 7. What is the largest possible value of their product? Okay, so first we need to interpret this into mathematical terms or expressions. So if we let these two numbers be represented by the variables x and y, so we say let x and y be the numbers. So let's express this into a mathematical expression. So two positive numbers now, so x and y, have sum 7. So that means x plus y is equal to 7. So we have now related the two variables, x and y, which are our knowns. Now, what is the largest possible value for their product? Could be interpreted this way. So the product is just equal to x times y. So etong product na to, this will be the function that we need to maximize because we need the largest possible value of the product. So that means we need to maximize p. Okay? Now, since we have already linked the relation between the two variables, we may now express one variable in terms of the other. So we could say from here that y is equal to 7 minus x. So to express the function in one variable, that would be p is equal to x times 7 minus x. Now, since we are maximizing p by applying maxima minima, the concept for maxima minima, we just need to get the derivative of p and equate it to 0. Diba? If you recall, at the highest point, at the highest and the lowest point in the curve, the derivative is equal to 0. So in this case, our function is p, which is a function of x. So therefore, at this point, p prime should be 0 at the highest and lowest point. Okay? So let's just get the derivative of this. So p prime is equal to x times negative 1 plus 7 minus x times 1. So that's by product rule, and we'll equate this to 0. So we'll have negative x plus 7 minus x is equal to 0. So we'll have 2x is equal to 7. So x is equal to 7 over 2. So the first number is 7 over 2. Now, to get for the second number, y, that would be 7 minus x. So 7 minus x. So therefore, y is equal to 7 minus 7 over 2, which is also 7 over 2. So that means these are our answers. For maximum product, the value of x and y should be the same, 7 over 2. Okay, if you want to verify our answers, let's just use this table mode in the calculator, our scientific calculator. So if we let y equal to f of x, so we'll start with f of x equal to 7 minus x. So f of x now is the variable y. Okay, and g of x is the product, so we'll take that as x times 7 minus x. So we could express it that way. Then since positive yung hinahanap, so we'll just start with 0, and let's end at 7 because the number in the domain is up to 7 naman. Or start at 0, end at 7, then step tagpo 0.5 para sure. So we'll get this table. So if you notice, if you look at the largest value for g of x, which is the product, so it's 12.25. Ayan. So it happens when the value of x is 3.5 and the value of y is 3.5. So our answer is correct. Now let's try this next problem. Two numbers have sum 16. What are the numbers if the product of the cube of one and the fifth power of the other is as large as possible? So again, maxima or maximization ulit of the product. So if we let x and y represent the two numbers again, so we let x and y be the numbers. So the relationship between the two numbers is that their sum is 16. So x plus y is 16. So what we need to maximize is the product of the cube of 1. So let's say that first number is x, the cube of x, and the fifth power of the other. So that would be the fifth power of the next variable, or y. So y raised to 5. So since we are taking the product as large as possible, then we are maximizing p. So therefore we'll have p prime equal to 0, which is true for both maximum and minimum products, values of p. So the first thing we need to do is to express one variable in terms of the other para isa na lang yung variable. So since x plus y is equal to 16, therefore y is equal to 16 minus x. So we could rewrite the product now as x cubed times 16 minus x raised to 5. Then eto na yung i-maximize. So to maximize this, we just need to get the derivative and equate it to 0. So we have p prime equal to x cubed times the derivative of this, that would be 5 times 16 minus x raised to 4 times the derivative of 16 minus x is negative 1, plus let's copy 16 minus x raised to 5 times the derivative of x cubed, which is 3x squared. Then we'll equate this to 0 since we are getting the maximum or the maxima. So let's simplify this, or should we just factor out x squared and 16 minus x raised to 4? So what will remain here would be negative 5x. So let me check that. X squared, so 5, okay. Negative 5x plus 3 times 16 minus x. Okay, 16 minus x pang naiwan. Okay. So equate that to 0. Okay, so in factored form, we'll have x squared times 16 minus x raised to 4. Then let's simplify this. That would be negative 5x plus 48 minus 3x. That's equal to 0. So we'll have x squared times 16 minus x raised to 4 times negative 8x plus 48 equal to 0. So we'll have three values for x. So we'll have x is equal to 0, or if x squared is equal to 0, then x is equal to 0. If 16 minus x raised to 4 is equal to 0, then x is equal to 16. And if negative 8x plus 48 is equal to 0, so we'll have x is equal to 48 over 8, which is 6. Now for the values of y, since y is equal to 16 minus x, so when x is equal to 0, y is equal to 16. When x is equal to 16, y is equal to 0, because that would be 16 minus 16, so y is equal to 0. So here the values are 0 and 16. Here the values are 16 and 0, and here the values are, so when x is equal to 6, y is equal to 16 minus 6, so y is equal to 10. So the values here are 6 and 10. So these are not coordinates. Okay, now which one of these will give the largest? So hinahanap natin is the largest product. Okay, so obviously if you take the product of this, or x cubed, diba the product is x cubed, sorry, p is equal to x cubed times y fifth, y raised to 5. So 0 na yung isa, so ma-0 to siya. As well as here. As well as here. The product here is 0. So it's not large compared to if we take this. So therefore, this is our answer. This is our answer. So for largest product, or that is p equal to x cubed times 1 raised to 5, x should be equal to 6 and y should be equal to 10. So this is our answer. So again, you may check that using a calculator. Checking this in our calculator, so let's get to mode table. So let's change these values. So let's start with f of x. Let's make that represent y. So y is 16 minus x, and g of x, that would represent the product of x cubed and 16 minus x raised to 5. Okay, so we'll start with 0. Let's end at 16 na lang. And step is sige, 0.5. So this is our value. So if you notice again, let's check asan yung pinaka-highest value. Ito siya. So that happens if x is 6 and y is 10. So the rest, ito na, yung kanina, mga minimum value yan. 0, 16, so the answer is 0. That's the minimum. Okay? Same as here. When x is 16 and y is 0, so the product is 0. So that would be at the middle. Yung highest natin is at 610. So let's now proceed to the next problem. Problem 6.3. A rectangular animal enclosure is to be constructed having one side along an existing long wall and the other 3 sides fenced. If 100 meters of fence are available, what is the largest possible area for the enclosure? Okay, for this problem, we have an existing wall, then an enclosure. Okay, so illustrate muna natin yung situation. So we have, let's say that is the wall, and we have a rectangular animal enclosure in which the other 3 sides are fenced. So let's just assume that this side is the shorter side. So naka-fence siya dyan, naka-fence din siya dito, then naka-fence din siya dito. Okay, so eto lang yung i-fence natin na sides. This one, and this one, because this side here is already an existing wall. Okay, then what we are asked here is if the available fencing is 100 meters, so meaning the total perimeter of the fence na available na kaya mong gamitin as fencing is only 100 meters. So meaning ito is 100 meters. So what is the largest possible area of the enclosure? Because there are many possibilities. You have a fixed length of fencing, but the configuration, so to speak, of your enclosure could be in many ways. So pwedeng ganito, mas malapad pero mas narrow. Pwede siyang ganyan. As long as the total of that fencing is 100. Pwede din siyang ganito. Diba? Pwede din siya mas narrower pa dyan, na side. Pwede ganyan. Pwede din dito. There are many possible setups. Basta ito lang yung constant, that the total fencing is just 100. So yun lang yung restriction natin. Okay? So these dimensions will give us the largest possible area. So yung i-maximize natin is the area. Okay? Now, if we assign some variables here, so when we say constant, diba? Constant is that doesn't change. For example, this 100 meter does not change because yun lang yung available natin na length of fencing. But the variables here are those that are changing. Okay? And these dimensions that are changing are, of course, this length and this width. So let's call this side as x, let's call this side as y. So this side is y as well. Okay? So these are now our variables because pwedeng yung y natin ganito lang, then ito, mas malapad yung x. Pwedeng yung y natin is mas longer, pero mas shorter na yung x. Okay, so the values are changing. That's why it's called variable. Okay, now to express this in terms of the other, or to relate these variables through the constant, we say that x plus 2y is equal to 100. We just interpreted this. Ito, if 100 meter of fence are available. So meaning, if this is our fencing, the total of this is fixed at 100. So that would be x plus y, or x plus 2y equals 100. That it's in meter. Now, what we are trying to maximize, or what we are maximizing, is the area of the enclosure. And we compute the area of a rectangle, because it's just rectangular, as x times y, or length times width. Okay? So, ito yung maximize natin. We need to maximize the area. Okay? Or maximize area A. So that means we need to get the derivative of this, whatever independent variable we are choosing as a variable for the area, or the single variable of the area, and we just equate that to 0. Okay, so A prime is equal to 0. So from here, we could relate, or we could express one variable in terms of the other. So para mas madali, we just express x in terms of y. So that would be 100 minus 2y. Para isa na lang yung variable natin for a. Okay? So that means area is equal to x, which is 100 minus 2y times y. Okay? So we just substituted. Now we have isa na lang na variable. Okay? So kung isa na lang yung variable, that means yung a prime natin is dA over dy. Yun yung equate natin to 0. So we just need to get the derivative of this, then equate that to 0. Okay? So a prime now is equal to, by product rule, that would be 100 minus 2y times the derivative of y with respect to y is just 1. So lagay na lang natin, plus y times the derivative of 100 minus 2y is just negative 2. And equate that to 0. Then simplify, we'll have 100 minus 2y minus 2y. That's equal to 0. So, negative 4y minus, negative 4y is equal to negative 100, no? Then y is equal to 25. So, since the given is in meters, the fencing, so y is 25 meters. So, if y is 25 meters, since x is equal to 100 minus 2y, that means x is equal to 100 minus 2 times 25. Which is equal to 100 minus 50, that's 50 meters. So this is now the answer for the largest possible area for this setup, okay, for the enclosure. So y, or this side, should be 25, and this side should be 50. And that is our answer. There is no question that what we have got is the largest, or the maximum, because ganito yun. If we need to get the minimum, we also use this condition that a prime is equal to 0, because at the minimum point sa graph, horizontal pa rin yung tangent dun. Diba? But, of course, klaro naman na yung minimum natin dito is 0 area. Diba? Masi-zero yung area pa for the minimum area. Because, ayan, if wala tayong value ng y, then it's all x, lahat x. So that would be our enclosure. Ganun lang, wala siyang area, so that's 0. That's the minimum area we could get. The same if wala siyang value, walang value yung y, puro siya, walang value yung x, puro siya y. So that would be this fencing lang, y is equal to 100, x is 0. Okay, so yun din yung minimum. So the minimum area for this enclosure is 0, wala. And the maximum area is this, 25 by 50. Now let's try this next problem. Problem 6.4. A lighthouse L is located on a small island 5 kilometers north of a point A on a straight east-west shoreline. A cable is to be laid from L to point B on the shoreline 10 kilometers east of A. The cable will be laid through the water in a straight line from L to to a point C on the shoreline between A and B, and from there to B along the shoreline. The part of the cable lying on the water costs $5,000 per kilometer, and the part along the shoreline costs $3,000 per kilometer. So letter A, where should C be chosen to minimize the total cost of the cable? And letter B, where should C be chosen if B is only 3 kilometers from A? Okay, the first thing we need to do is to visualize this problem or to interpret this geometrically. Okay, let's start with ito. So, meron tayong lighthouse L located on a small island 5 kilometers north of a point A on a straight east-west shoreline. So, let's just first draw that east-west shoreline. So, let's say this. This is the shoreline. Ayan. So, let's say this is our point A, and 5 kilometers north of that is the island. Let's say that is point L, which is directly 5 kilometers above. To the north, I mean. This is 5 kilometers. Now, a cable is to be laid from L to point B 10 kilometers east of A. So, we have another point B east of A. So, this is point B, which is 10 kilometers east. So, this is 10 kilometers. Then, we need to lay a cable. Okay, so, ito yung setup natin. From here, pa ganon, di ba? Pwedeng pa ganon. I think that would be the shortest, obviously. The shortest length of the cable. The cable will be laid through the water in the straight line from L to a point C on the shoreline between A and B. So, we will choose a point between A and B. So, that will be point C. To which, from L, doon natin i-direct yung cable natin through the water. Kasi, di ba, tubig to. This is an island. Tapos, this is a body of water. Then, eto yung shore natin, yung shoreline. Okay? So, from the along the shoreline, between A and B, doon tayo kukuha ng point C, then doon natin i-direct yung cable natin on the water. Then from here, doon na natin idugtong siya papunta sa point B. Okay? So that is the situation sa problem na to. Okay? The cable will be laid through the water in a straight line from L to a point C on the shoreline between A and B, and from there to B along the shoreline. So ayun na. So from point C along the shoreline na. So the part of the cable lying in the water costs $5,000 per kilometer, and the part of the shore and the part along the shoreline costs $3,000 per kilometer. So meaning mas mahal yung cost pag maglay ka, ipadaan mo siya sa water. Then mas mura dito. Okay? Kasi $5,000 per kilometer yung cost, dito naman is only $3,000 per kilometer. So, pwede yung setup mo ganito. Hindi ka na gagamit ng, hindi mo na siya iparun along the shoreline, diretso ka na lang dito, pero mas mahal siya. Diba? Shorter yung distance mo along the water, diba? Pero, it's more expensive. So, gusto mo i-minimize mo lang yung gasto mo along the water. So, eto na siya. The problem is, mas mahaba na yung dito sa along the shoreline. So, gagasto ka pa rin because although it's more cheaper, pero the distance is more longer. Okay? The farther the distance, the more expensive pa rin because you need to multiply this by the distance because that is per kilometer. So, maraming possibilities ang pwede mong gamitin. But which of these possibilities will give you the least cost? Okay? The minimum cost. So, pwede siyang ganito, then dito. Pwede siyang ganito, then dito. Pwedeng ganyan, 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 and finally, pwede siyang ganyan. Diba? So, for minimum cost, asan the banda si C or yung point C from, let's say, point A or point B. So, we just choose kung asan yung maging reference natin. Okay? So, yun yung kailangan natin i-solve for letter A. where should C be chosen to minimize the total cost of the cable? So let's say C would be around here. So let's call this point C. So if we run the cable from here to here, ganyan, then here to here, that would be our setup. The question is, this would be, where should C exactly be? So ang variable natin dito is the distance of C either from A or from B. So we just choose. So eto, gawin na lang natin from A. So ang variable natin dito is eto, this distance from A. So I'll call that X. Again, kasi pwede din naman siya yung X, eto lang yung X, diba? Ganyan lang. Pwede din siya dito, mas mahaba yung X. So it's a variable because it could change. So ang gawin natin, let's create the formula for the cost first na lang. Okay? Kasi yung i-minimize natin. So we need to minimize the cost. So let's call that C. That means we need to get C prime and equate that to zero. Okay? Now, we need to get the equation for C. So, paano natin i-compute yung cost? So, paano natin i-compute yung gasto dito? Of course, that would be the price times the length. Diba? Kasi yung if the length is only 1 kilometer, so the price of that is just 5,000 kung nasa dagat. Diba? That would be $5,000 per kilometer. Multiply that by kung pila ka kilometer or kung ilan yung distance, let's say 1 kilometer. So that would be the cost. Diba? 5,000. So in this case, the cost would be the sum of the cost at sea. Ganito na lang. The cost through the water plus the cost through the shore. And by price naman siya. So cost is just price times the quantity. So cost is for the water is just 5,000 times the length of the cable through the water. So what I mean is this one, eto. So I call that length of the cable through the water. Naka-L na tayo dito, no? To avoid confusion, the small letter natin, small letter L. Ayan. So yan, length of the cable through the water, then plus 3,000, mas mura, times the length of the cable along the shore. Okay, so that would be this, C to B. So I'll call that L S, L sub S. Okay? So ganun lang yung cost natin. So, let's now express these two lengths in terms of the variable. So, ito yung variable natin, di ba? So, of course, if this is X and this is 10 kilometers, that means ito siya. Ito siya. Ang LS is just 10 minus X. Ganun siya kadali. This distance from C to B is just 10 minus X. Okay? How about itong L along the water? So, if this is X kilometers and this is 5 kilometers, we can now solve for this through Pythagorean lang or Pythagorean. Okay? So, that would mean that L sub W is just equal to the square root of 5 kilometers. So, unahin natin yung X. X kilometers squared plus 5 kilometers squared. So, LW, so that's square root of X squared plus 25. So, meron tayong equation in terms of one variable. So, C now is equal to 5,000 times the length, which is the square root of, along the water, square root of X squared plus 25 plus 3,000 times the length dito from C to B, that would be 10 minus X. So, isa na lang yung variable natin. We could now get the derivative of C with respect to X and equate that to 0. So, madali na. So, let's now try to solve for C prime. So, C prime now is equal to, this is just a constant. And we know, okay, from what we have discussed and learned before, we know that the derivative of the square root of U, the derivative of that is just the derivative of U over 2 times the given 2 square root of U. Ganon. So that means we just need to get the derivative of this inside. So that's just 2x over 2 times the square root of x squared plus 25. And I could just cancel out 2. So, tapos na. Ganun lang siya kadali. Then, plus 3,000, because this is constant, times the derivative of 10 minus x, of course, is just negative 1. Right? The derivative of negative x is negative 1. And equate that to 0. Okay. Now we have 5,000x over square root of x squared plus 25 equal to, let's just transpose that to the other side, that would be 3,000. And it's a matter of algebra na lang to solve for the value of x. So 5,000x is equal to 3,000 times square root of x squared plus 25. Or pwede din natin i-divide na lang by 3,000 both sides, no? O, pwede rin. So that would be 5/3 x. That's equal to the square root of x squared plus 25. Then how about we square both sides? That would be 25 over 9x squared. That is equal to x squared plus 25. So that would be 25 over 9 minus 1. So 25 over 9 minus 9 over 9, that would be 16 over 9. So we have 16 over 9 x squared, that's equal to 25. Transpose to the other side, so that would be 25 times 9 over 16. Take the square root of that, x is equal to, actually that's positive, negative, no? Ito na lang, square root of 25 is 5, square root of 9 is 3 over square root of 4, which is, square root of 16, which is 4. So our answer, x, is 15 over 4, right? So 15 over 4, positive, negative, we'll just take the positive, 15 over 4 kilometers, or that would be 3.75. Okay, that's in kilometers. So, meaning C should be located at 3.75 kilometers from A in order to minimize the cost of sa pag-layout ng cable. Okay. So, we use the positive value here because kung negative yung ginamit natin, that would, the setup would be, eto yung positive x kasi natin. Kung negative yung i-consider natin, that would be this. So, pag ganito na yung setup, so that would not be the least cost kasi mas gasto ka. Diba? Mas malayo yung na-run ng cable. So, positive yung ginamit natin because that would be this distance. So, that length of cable. Okay? Then that would be our answer. Okay, let's try this one. Fifth problem for this topic. Find the shortest distance from the point 50 to the curve 2y squared equals x cubed. Okay. So, unang gagawin natin dito is to graph this, to locate this point in the graph and also to graph this function. Okay, let's do that. And the curve is 2y squared equals x cubed. Okay, we have this curve. Okay. Ito lang muna. Okay, so let's zoom this in. Okay, this is now the graph of the function. So, ang hinahanap natin is the shortest distance from this point to this curve. Okay? So, that could be right here or pwede din naman dito, no? Pareho lang because it's a mirror image. So, which of these distances to the curve is the shortest? Okay? So, that means, ano yung i-minimize? What quantity do we need to minimize? So, we need to minimize the distance. So, let's call that D. So, let's assume that that is right around here. Okay? So, this distance is D. Okay? Or, let me use capital letter na lang. Kasi yung derivative natin is in D. So, capital letter D na lang tayo. So, this. Okay, so we need to minimize D. And, of course, we need an equation for D. And the equation for D is simply the distance formula, because we're dealing with the distance between 2 points, and this point here is still unknown, so we'll just call that x and y. Okay, coordinates x and y, which is a variable. We don't know because it could be right here. This could be the shortest. It could be right here. This could be the shortest, or right here. That could be the shortest. We don't know. So that is our x and y. So to get the distance from x, y, this point to here, which is just the same if yung x, y natin nandito, to get the distance, we just use a distance formula. Okay, so distance squared, looking at the graph, distance squared is just equal to the equal to x minus 5 squared plus y minus 0 squared. So that would be our equation. Then we just need to get the derivative of the distance and equate that to 0 to get the minimum. Okay, then let's just simplify this. We'll have d squared, that's equal to x minus 5 squared plus y squared, and we still have two variables. But the given is ito. The given is that 2y squared is equal to x cubed. Therefore, if 2y squared is equal to x cubed, that means y squared is equal to x cubed over 2. Okay, then we just need to substitute this here para isa na lang yung variable natin. So we'll have x squared equal to x minus 5 squared plus y squared, which is x cubed over 2. Then we'll just get the derivative. So mag-implicit na lang tayo. Anyway, we just need to equate that to 0 para maiwasan natin yung square root, because if we square both sides, so we need to get the derivative of the square root. So for me, that would be complicated. Since maxima minima naman, we just pwede natin i-solve siya through implicit na lang. So the derivative of d squared, implicit differentiation, that would be 2d d prime, right? Because we are getting the derivative of d with respect to x. So 2d d prime, that's equal to 2x minus 5 times 1 plus 3 halves x squared. Then if d prime is equal to 0, then we could just cancel this out. That would be equal to 0. So we are left with 2 times x minus 5 plus 3 halves x squared. Then all we need is to get the value of x. So madali na lang. We'll have 2x minus 5, minus 10 plus 3 halves x squared. Okay, so arrange natin to 3 halves x squared plus 2x minus 10 equals to 0. So we have a quadratic equation. So pwede tayong gumamit ng quadratic formula or maybe completing the squares. So if we do completing the squares, pwede ba? Or quadratic formula na lang. So x is equal to negative b plus minus square root of b squared minus 4ac over 2a. You know that. So a here is 3 halves, b is 2, and c is negative 10. Then let's just substitute. So x is negative b plus minus square root of b squared minus 4ac over 2a. So let me simplify that. That would be negative 2 plus minus square root of 4 plus 60. So that will be 64 over 3. Okay, let's now solve for x. So we have two values of x. If we use plus, so we have negative 2. So square root of 64 is 8. So we'll use plus first. So negative 2 plus 8 over 3, that would be 6 over 3. So x is 2. And if we use now negative 8, so negative 2 minus 8 over 3, that would be negative 10 over 3, or negative 3.3333. So we have two values of x. One is positive 2. So dapat nandito siya banda. Ito. Asa dapat ito? Ito pala. Nandiyan pala yung shortest, no? Okay, yung isa naman is negative 3 point something, nandito na. So obviously, sobrang layo na niyan. Okay, kasi negative 3. So andun na sa kabilang part of the Cartesian. So meaning, this, if we are looking for the shortest, then ito yung magme-make sense. So ito na lang yung gamitin ko. Okay? So let's solve for y. We know that 2y squared is equal to x cubed. So if we have 2y squared equal to 2 cubed, so we have 2y squared equal to 2 squared. So y is also equal to 2. Ayan, na-trace naman dito. Ayan. So yan pala yung shortest distance natin. So I'll just correct this. I'll use this green, another color. The shortest distance is ito pala. That is the shortest distance. Okay? Shortest distance. So for shortest distance, yung nearest point is 2, 2. But yung hanapin natin is the shortest distance, the value of d. So therefore, we say that the closest point to 5, 0 is 2, 2. So if that's the case, let's solve for the distance. That would be square root of 2 minus 5 squared plus, we're simply getting the distance from 2 to 5, 0. Okay, so distance formula ulit. So 2 minus 5 squared plus 2 minus 0 squared. So d is equal to the square root of 9 plus 4. So therefore, the shortest distance is square root of 13 units. So this is our answer. Square root of 13 units. So I think 5 examples is enough for this video. We'll just solve more problems involving maxima, minima, or application of maxima, minima during our classes. So see you in the next video.